Hi everyone, welcome to Numeric Learning and welcome to Do Math with Me series. So we are in day 40 and today we'll be doing a lot of questions from the chapter 8, which is Introduction to Trigonometry. I've got a set of 35 to 40 questions today. So please take your notebooks and you can do along with me. All of these questions are very important questions. Let's get started. The first question for the day is, given tan theta is equal to 1 by root 5, you have to find the value of cosecant square minus secant square divided by cosecant square plus secant square. So cosecant and secant, there has to be, you should know an identity which relates cosecant with cot, secant with tan, right? So let's get started. Let's write the expression that we are given. So it is nothing but cosecant square theta minus secant square theta whole divided by cosecant square theta plus secant square theta. So you should already be knowing an identity which is cosecant square theta is nothing but 1 plus cot square theta. Okay, so this is something which you have to remember. Cosecant square equal to 1 plus cot square. Okay, minus secant square is equal to 1 plus tan square theta whole divided by, because we are only if we convert cosecant to cot and secant to tan will we be able to apply tan theta value, because cot is nothing but 1 over tan, right? So whole divided by, in the denominator you have cosecant square again, so it's nothing but 1 plus cot square theta plus, again I'm going to convert secant to tan, which is 1 plus tan square theta. So just open the bracket. So what do you get? 1 plus cot square theta minus 1, minus into plus, right? Minus into 1 is minus 1, minus into plus is minus tan square theta. Okay, whole divided by 1 plus, again it's 1 plus 1, I'll directly write it as 2. Okay, 2 plus cot square theta plus tan square theta. Okay, this plus 1 minus 1 gets cancelled. How can I write cot square? Cot square can be, so let's write whatever is left. So cot square theta minus tan square theta is left. So I'll write cot square theta is 1 by tan square theta minus tan square theta whole divided by, again 2 plus 1 over tan square plus tan square. Okay, so you can just replace. So tan theta is 1 by root 5. So what is tan square theta? It will be 1 by 5, right? So if tan theta is 1 by root 5, what is tan square theta? You have to just take the square of it, which is 1 by 5. So I'm going to just replace tan square theta with 1 by 5. So 1 by 1 over 5, okay, minus 1 by 5 whole divided by 2 plus 1 over 1 by 5, which is 5, plus tan square theta is again 1 by 5. Okay, so here this you will be getting it as 1 over 1 by 5 is nothing but just 5. So 5 minus 1 by 5 divided by 5 plus 2. 2 plus 5 is 7 plus 1 by 5. Take the LCM. The denominator will get cancelled. So it's 25 minus 1 by 5. Okay. Whole divided by 7 5 is 35 plus 1 by 5. Okay. This by 5 will, the denominator 5 will get cancelled. So what is left is 25 minus 1, which is 24, whole divided by 35 plus 1, which is 36. Okay, you can cancel it. 12 2 and 12 3s are, so the answer is 2 by 3. Okay, so for doing this question, one important thing that you have to note is the identity, that is you should know cosecant square theta is equal to 1 plus cot square theta is one identity that you have to learn, and the other one is secant square theta is equal to 1 plus tan square theta. Okay, so these are the two identities which are important, and you can even make a note of it while doing the question. Okay, I hope it's clear. So this is your final answer. Let's move on to the second question. So prove that sine plus cosecant theta the whole square plus cos plus secant the whole square equal to 7 plus tan square plus cot square theta. Again, you just have to expand it using a plus b the whole square. Let's take our LHS and expand it using a plus b the whole square. So sine square theta plus cosecant square theta plus 2 sine theta cosecant theta. Okay, a square plus b square plus 2ab plus cos square theta plus secant square theta plus 2 cos theta into secant theta. This cos theta and secant theta, you know that secant theta is nothing but reciprocal of cos. Okay, so this is nothing but, so this particular 2 sine into 1 over sine, right? Cosecant is nothing but 1 over sine. Similarly, this expression will also become 2 cos into 1 over cos. Okay, secant is nothing but it's the reciprocal of cos. Cosecant is the reciprocal of sine. So sine and sine will get cancelled, cos and cos will get cancelled, right? This here, what is sine square theta plus cos square theta? It is equal to 1. So I'm going to write a 1 here. Okay, 1 plus. Okay, what do I need? I need RHS in terms of tan and cot, and we just saw an identity wherein you can convert cosecant into cot and secant into tan. So let's just apply that. So what is cosecant square equal to? It is 1 plus cot, right? 1 plus cot square theta. Okay, plus there is a 2 here, plus secant square is nothing but 1 plus tan square theta. Again, a plus 2 is left because cos into secant will get cancelled. Sine and cosecant will also get cancelled because they are reciprocal to each other. Now you can add all of these. 1 plus 1 is 2, 2 plus 2 is 4, plus 1 5, plus 2 7. So what is it that you're getting? 7 plus cot square theta plus tan square theta is what you're getting, and that is your RHS, right? This is equal to your RHS, right hand side, hence proved. Again, so in order to solve this question, what is it that you needed? First of all, you have to expand it using a plus b the whole square, and then you should know to cancel this. Sine is sine multiplied by cosecant can be written as 1 over sine. Cos and secant can get cancelled with each other because they are reciprocal, and then cosecant equal to 1 plus cot square, secant is equal to 1 plus tan square. It's the same identity that we used in the previous question. Okay, so let me write that again. So you have to learn, if you haven't, that is cosecant square theta is equal to 1 plus cot square theta, and secant square theta is equal to 1 plus tan square theta. Very important. Okay, and we already know sine square theta plus cos square theta is equal to 1. This is also very important, right? So this is how we have to do. Let's move on to the third question. Prove that 1 plus cot A minus cosecant A multiplied by 1 plus tan A plus secant A is equal to 2. So what do you see here? Everything is getting cancelled, right? In the RHS, it's just an integer. That means everything will get cancelled. So let's convert. In such questions, what you have to do is take your LHS and convert everything into sine and cos. Okay? So take your LHS. 1 plus, what is cot? Cot is nothing but cos by sine. Okay, I'm just writing cos as C, sine as S. Minus cosecant is nothing but 1 by sine. Okay, multiplied by 1 plus tan is nothing but sine over cos plus secant is nothing but 1 over cos. This is my LHS. Take the LCM. Sine is the LCM. So you have sine plus cos minus 1 on one side. Okay. And the second term is take cos as LCM. So you have cos plus sine plus 1 as the LCM, I mean, in the numerator. Okay, so this is nothing but, you can see this as a plus b into a minus b, right? A minus b into a plus b. So I can write it as a square minus b square. Okay, just a product, right? A plus b into a minus b divided by sine into cos. Okay, so this is nothing but, again you have to expand it, that is sine plus cos the whole square, a plus b the whole square. So it is nothing but sine square plus cos square minus, sorry, plus 2 sine cos plus 2ab minus 1 whole divided by sine into cos. Okay, so what is this? Sine plus cos, sine square plus cos square, it is just 1. So 1 plus 2 sine theta cos theta minus 1 divided by sine theta cos theta. So 1 plus 1 minus 1 gets cancelled. You have 2 sine theta into cos theta divided by, you have sine theta into cos theta. Okay, so which is nothing but, all the terms get cancelled and you get a 2 here. So which is equal to your RHS. Okay, I hope you understood. So when you are doing, you can write C for cos and S for sine entirely. Okay, so this is how you have to do. Let's move on to the next question. Yeah, here you have to prove that 2 cos cube theta minus cos theta divided by sine theta minus 2 sine cube equal to cos. Again, this is a frequently asked question. I have also done it in the previous videos. So let's do it. Just take cos common, take your LHS, take cos theta common. So what you have here is 2 cos square minus 1 divided by, again take sine theta common out. So you'll have 1 minus 2 sine square. Correct? So now we should know, you can see cos over sine is cot. So this is something which you already got. So what we can now do is convert cos square as 1 minus sine square. So here you have 2 multiplied by 1 minus sine square minus 1 whole divided by sine into 1 minus 2 sine square. So open the brackets inside. So c into 2 ones are 2 minus 2 sine square minus 1 whole divided by sine multiplied by 1 minus 2 sine square. Again 2 minus 1 is 1. So you have cos multiplied by 2 minus 1 is 1 minus 2 sine square theta whole divided by, you have sine common out, 1 minus 2 sine square. So 1 minus 2 sine square gets cancelled. So what is cos theta over sine theta? It is nothing but cot theta. And that is your RHS. Hence proved. Okay. Again, very easy question. You can do it either ways. So the minute you take your cos and sine common out, cos by sine is cot. So you have to, you have to cancel these terms. Either, now what we have done is we have converted cos square into 1 minus sine square. Otherwise, you can keep the numerator as such and convert sine square into cos square, and even then it will get cancelled. Okay, so that's all. So the minute these terms get cancelled, what you are left is just cos by sine, which is nothing but cot, which is your RHS. Okay, let's move on to the next question. Yes, here all of these questions that we are doing today, these are all proving the trigonometric identities. So the next question is 1 plus cot A plus tan A multiplied by sin A minus cos A is equal to sin A tan A minus cot A cos A. The best way to do here is, again, convert everything into sin and cos. So take your LHS, and before that, just multiply everything. Okay, just multiply. So multiply these two terms. These are just product of two expressions, right? 1 into sine, then plus, okay, and then 1 into minus cos, then cot into sine, cot into cos, tan into sine, tan into minus cos. Just open the brackets and multiply all of these terms. So what do you get? So you get sin A minus cos A plus cot A into sin A minus cot A into cos A plus tan A into sin A, and then minus tan A into cos A, right? So I'm just going to replace it and see, and then convert everything into sine and cos. Okay, I'm going to convert these so that I can cancel it. See, cot, I'll convert it as cos over sine, again cos over sine, sine over cos, sine over cos. And let me see let's see how to proceed. Okay, so sine minus cos plus cos by sine multiplied by sine minus cos over sine multiplied by cos plus tan is nothing but sine over cos into sine minus sine over cos multiplied by cos. Okay, so I just converted cot as cot and tan in terms of sine and cos. Okay, so here sine and sine gets cancelled. So what we are left with is sine A minus cos A plus cos A minus cos square by sine. Yes, let's just keep this, okay, into cos plus sine square, sine by cos into sine minus sine. Okay, so this plus sine minus sine gets cancelled, plus cos minus cos gets cancelled here. So what I finally have here is nothing but minus cot A into cos A plus I have sine over cos is tan A multiplied by sine A. Right? This is what I have. And this is what is my, so I can rearrange it and write it as sine A tan A. So here I'm just going to rearrange the terms. So this is nothing but sine A into tan A minus cot A into cos A. Okay, so that's all this is your RHS. See here, look at your RHS. Sine into tan minus cot into cos. Sine into tan minus cot into cos. So that's the reason why we did not multiply and write cos square by sine or sine square by cos, because what we need in the RHS, we have a cot here, right? That's why we did not multiply these two cos or these two sine. We did not multiply because what we needed is this term. We needed a sine and a tan in the RHS side. Okay, so that's the reason why we kept it as it is. I hope you understood. This is equal to your RHS. Let me know if you have not understood. Let me tell you once again how to do it. Just take the LHS, okay, and multiply these two terms, one term with each term with all the terms of the second expression. So, and once you expand it, first of all, convert everything into sine and cos, so that there are certain terms which will get cancelled in both the places here. Yeah. Cot A is nothing but cos by sine. Sine and sine will get cancelled. And here also, tan, sine over cos, cos and cos will get cancelled. Right? All the other terms you can keep it as it is. So when you expand it, you can see here one sine minus sine, one cos plus and minus cos will get cancelled. What you are left with is just two terms. You can keep it as it is, keeping in mind whatever you need here. Right? So cos over sine is cot. Keep the cos as it is. Sine over cos is tan. Keep the sine as it is. So this is what you say RHS. So whenever you're proving anything, keep an eye on what you need in the RHS. What do you have to prove? Okay, that is something which you have to derive at. Right? So I hope you understood. Let's move on to the sixth question of today. Okay, this is a very, very similar question to another one that we did here. Yes, here. 2 cos cube minus cos by sine minus 2 sine cube. It's a very similar question. Let's do it. Let's take our left hand side. Take sine A common. So what you are having inside is 1 minus 2 sine square divided by, again take cos common. So you have 2 cos square minus 1. Again, sine by cos, see we have already got sine by cos is tan. Now we have to cancel these other two terms. How will we do? Let's convert the numerator sine square into 1 minus cos square. So you have sine multiplied by 1 minus 2 into sine square. I'll write it as 1 minus cos square. Okay. Whole divided by cos a multiplied by 2 cos square a minus 1. Okay. So here you'll have sine a multiplied by 1 minus 2 plus 2. Just multiply this minus 2 into 1 minus 2. Minus 2 into minus c square. Minus into minus is plus 2c square. Okay. Whole divided by, you have cos a into 2 cos square minus 1. Okay. So here what you have here, sine multiplied by 2 cos square, I'll write it. Minus 2 plus 1 is minus 1 divided by cos a into 2 cos square minus 1. So this 2 cos square minus 1 gets cancelled in the numerator. What you are left with is sin a by cos a, which is equal to your tan a. That's nothing but your RHS, hence proved. Okay. For my own simplicity, I always write sine in terms of, I'll just abbreviate sine as S, cos as C, and tan as T. Okay, so that the variable, it is in terms of variable and not everywhere. But when you are doing it, you can write it entirely. Right, let's move on to the next question. Again, here also, it's a very easy question, very good question. You are given LHS in terms of tan and cot. What you are asked is also in terms of tan and cot. The best approach to do is again convert everything into sine and cos. Okay, so take your LHS and let's write tan in terms of, tan is nothing but sine by cos divided by 1 minus cot is cos by sine, plus cot A is cos by sine divided by 1 minus sine by cos. Okay, so here, so this is nothing but sine by cos whole divided by, you will have sine minus cos by sine plus cos by sine is the numerator divided by, take the LCM, so you will have cos minus sine by cos when you are taking the LCM. And here, whenever you have fractions, take the uppermost, the numerator of the upper with the denominator of the below will get multiplied, and the numerator of the below fraction with the denominator of the above fraction will get multiplied. So it will always get, so whenever you have two fractions, it will get multiply in this manner. So what do you get here? This is nothing but s square, s into s square whole divided by c multiplied by cos multiplied by sine minus cos. Okay, plus again cos square divided by sine multiplied by cos minus sine. Okay, so in here one side you have sine minus cos, the other side you have cos minus sine. So if you take one negative, one minus one common out, this will also become sine minus cos. So let's do that. Take one negative common out from the next term. So the first term remains the same, sine square divided by cos multiplied by sine minus cos. Take a negative sign, 1 minus 1 common out, so you'll have minus 1 you have taken common, so the denominator will become sine minus cos. Now take 1 by sine minus cos common out. What is left inside is sine square divided by cos minus cos square divided by sine is what is left. Take the LCM. So what you have taken common is sine minus cos is common. Within the square bracket, take the LCM. So you have cos sine is the LCM. Numerator, you'll have sine cube minus cos cube. What is a cube minus b cube? So you have sine minus cos is common out. A cube minus b cube is a minus b multiplied by a square plus b square plus ab. Okay. Whole divided by, what is the LCM? Sine and cos. Okay, so sine minus cos will get cancelled. What do you need? You need 1 plus tan a plus cot a. Okay, 1 plus tan a plus cot a. Okay, so now what you'll do, what you are left with is sine square plus cos square plus sine cos whole divided by sine into cos. Just split up the denominator term into all the three terms. So what is it? Sine square divided by sine cos plus cos square A divided by sin A cos A plus sin A cos A divided by sin A cos A. So this will become 1. 1 cos and 1 sin will get cancelled. So what is left is sin by cos. Sin by cos plus cos by sin plus 1. What is sin by cos? It is tan A. What is cos by sin? It is cot A plus 1. It's your RHS. Isn't it? Is that your RHS? Yes. You can rearrange it and write 1 in the beginning. So you can write it as 1 plus tan A plus cot A. Okay. This is your RHS. Hence proved. So very, very easy questions. So all of these pattern of questions is something you should practice. Okay. The questions wherein you have tan, cot in the LHS and RHS also something which you have to prove. Convert everything into sin and cos and just solve. Take LCM very carefully. Use this identity, algebraic identity very carefully. That is a cube minus b cube is equal to a minus b into a square plus b square plus ab. Okay. Just keep in mind what you have to achieve, the goal that you have to prove, right? That expression is something which you have to get into. Now, many students, you know what mistake they make. Okay, at this point, once they reach this point, they write sine square plus cos square as 1. So what will happen is it will become 1 plus sine cos divided by sine cos. So this will be 1 by sine cos plus sine cos by sine cos, right? This will become 1. So this is nothing but 1 over sine is cosecant multiplied by secant plus 1. So if this is the identity that you have to prove, then you have to take, if this is what you have to prove, cosecant theta into secant theta plus 1. Okay, if this is what you have to get to in the RHS, then you have to convert the sine square plus cos square as 1. Otherwise, if you have got 3 different terms, right, 1 plus tan A plus cot A, then you should not use sine square plus cos square equal to 1, because otherwise you will not be able to get tan A plus cot A plus 1. Okay, you need 3 different terms here. I hope you understood. So depending on what your RHS is, you will have to modify and check. Let's move on to the next question. Yeah, you are given cos theta is equal to root 3 by 2. You have to find a value of cosecant minus secant square divided by cosecant square plus secant square. So what is cos theta? Cos theta, you are given cos theta is nothing but root 3 by 2. Cos theta is nothing but base by hypotenuse, right? So using Pythagoras theorem, we know that h square equal to p square plus b square, right? So what is your p square? P square will be nothing but h square minus b square. What is h? So here, let your base be root 3x. Okay, your hypotenuse is 2x. So just let's substitute. Hypo is 2x the whole square minus base is nothing but root 3x the whole square. So what you get? 2x the whole square, it's 4x square minus root 3 the whole square is 3x square. So this is just 1x square is your perpendicular square and perpendicular is just 1x. Okay. Now, once you've got your perpendicular, what do you need? You just need secant and cosecant. So what is the formula? What is the T ratio for cosecant? So cosecant theta is nothing but h by p, hypo by perpendicular. What is h? It's just 2x divided by 1x, 2 by 1, right? Which is nothing but is equal to 2. And what is secant theta? It is the reciprocal of cos, isn't it? Cos is b by h. So this is h by b. What is h? 2x. What is your base? B is root 3x. So this is nothing but 2 over root 3. That's all. You have got cosecant theta and secant theta value. Just substitute it here. So what you have to find is cosecant square theta minus secant square theta whole divided by cosecant square theta plus secant square theta. Just substitute. So this is nothing but 2 square minus 2 by root 3 the whole square whole divided by 2 square plus 2 over root 3 the whole square. So this is nothing but 4 minus 4 by 3 whole divided by 4 plus 4 by 3. So when you take the LCM, what do you get here? 12 minus 4 by 3 will get cancelled anyway. So it's nothing but 12 plus 4 by 3. Okay, this is what you get it. So this by 3 will, denominator 3 will get cancelled in both numerator and denominator fraction. So what you have is just 12 minus 4 divided by 12 plus 4. So what is 12 minus 4? 8. 12 plus 4 is 16. This is nothing but 1 by 2. This is your answer. Okay, again, a very, very easy question, probably a 2 or 3 mark question. I should be able to do it. Very straightforward question. Let's move on to the next one. The 7th. Okay, is it the 9th question? Yeah, 9th question for today. If sine theta is equal to cos theta, then find the value of tan square plus cot square. Again, very easy. So you are given sine theta is equal to cos theta. Okay, either you can divide both the sides by cos theta. In that case, what do you get if you divide both sides by cos theta? What do you get here? You will get sine theta by cos theta is equal to cos by cos, which is 1. So you are getting tan theta is equal to 1. Okay, see, you have to find the value of tan and cot. If tan theta is equal to 1, what is cot? Then cot theta is nothing but 1 over tan theta, isn't it? Tan theta is 1. So 1 over 1, which is also 1. Therefore, what is the value for tan square theta plus cot square theta? It is just 1 square plus 1 square, which is 2. That's all. So very, very easy question. Based on what you're given, you have to just convert it into what you need. Okay, let's move on to the 10th question for today. If tan plus cot is given as 4 root 3 by 3, find the value of tan square plus cot square. See, you are given a plus b is equal to some value. You are asked a square plus b square. So how do you convert a plus b into a square plus b square? When you take square, right? When you do the squaring, what you'll have is a plus b the whole square. So a square plus b square, right? So let's do it. Let's write what is given. You are given tan theta plus cot theta is equal to 4 root 3 by 3. Okay. Let us square on both the sides. Squaring both sides. So when you square both the sides, this will become tan theta plus cot theta, the whole square is equal to 4 root 3 by 3 the whole square. Again, a plus b the whole square. A square plus b square plus 2ab is equal to 4 root 3 the whole square. So 4 4s are 16. 16 multiplied by 3 whole divided by 9. Right? So you can just 3 ones are, so this is nothing but 16 by 3 is what you are getting here. This again will get cancelled. See, this is nothing but tan multiplied by 1 over tan, right? This will get cancelled. So what you have here is tan square plus cot square. So that's what we need, right? You have to find the value of tan square plus cot square. So tan square theta plus cot square theta plus 2, because tan and cot, they are reciprocal to each other, right? So that will get cancelled, is equal to 16 by 3. So what is tan square theta plus cot square theta is equal to 16 divided by 3 minus 2. When you take the LCM, 3, so you have numerator, the first term is 16 minus, so 1, 3, 3 2s are 6. So this is nothing but you're getting it as 10. 16 minus 6, 10 by 3. That's your answer. Right? Again, very, very easy question, very straightforward question. Let's do another question of a similar kind. Okay, so you are again tan plus cot is given, but you're asked tan square plus cot square minus 4 is something you have to find. Let's do it the same way. You can pause the video and try doing it. Okay. So since it's a video, you can definitely pause it. Tan plus cot theta equal to 6. And then we have to squaring both the sides. Squaring both the sides. So what do you have? Right, writing the steps is very important. So tan theta plus cot theta, the whole square is equal to 6 square. Don't write directly. Okay. And then you expand it using a plus b the whole square. So tan square theta plus cot square theta plus 2 tan theta into cot theta is equal to 36. Right. So again, here also you will have tan theta multiplied by 1 over tan theta. Okay, so it will get cancelled. It's 1. So 1 into 2 is 2. Okay, so here I'm just going to rewrite it. Tan square theta plus cot square theta plus 2 is equal to 36. Right? So what is tan square theta plus cot square theta? Will be equal to 36 minus 2, which is 34, right? But what is the expression that we are asked? We are asked tan square theta plus cot square theta equal to 34, but we are asked minus 4 also. So this is the value that we have to find, tan square plus cot square minus 4. So what you can do is subtract 4 on both the sides. Subtract 4 on both the sides. So what do you get here? Tan square theta plus cos square theta minus 4 is equal to 34 minus 4, which is equal to 30. So this is your final answer. The value that you have to find is 30. Okay. Okay. So that's it. It's very easy. I think both the 10th and the 11th question were of a very similar kind. Right. So the minute you see something of the form, say a plus b, and you're asked a square plus b square, immediately squaring is one of the best options to go about. Let's move on to the next question. Yeah. Here, prove that tan minus cot divided by sine into cos equal to secant square minus cosecant square. Very, very good question. Very important question as well. Okay. Let's just take our LHS and convert everything into sine and cos. Okay. So what is tan theta? Sine over cos minus cot is nothing but cos over sine, whole divided by sine into cos. Right. Take the LCM in the numerator. So what is it? Cos sine. So you'll have sine square minus cos square divided by sine into cos. Right. This I can write it as by 1. And I told you, right? How do you do when you have a fraction divided by fraction? Then numerator of the above fraction with the denominator of below fraction. These are the two terms. And then the denominator of the upper fraction with the numerator of the below fractions will get multiplied. Okay. So here what you have here is sine square minus cos square divided by sine into cos multiplied by sine, cos into sine, which is sine square into cos square. Right? Okay. Now, what you need here is cosecant minus secant square minus cosecant square. So what I can do is I'll just split it up. So sine square divided by sine square cos square minus cos square divided by sine square cos square. So cos square gets cancelled, sine square gets cancelled, and what is left is 1 by cos square theta minus 1 over sine square theta. What is 1 over cos square theta? It is secant square theta. Minus 1 over sine square theta is cosecant square theta. Secant square minus cosecant square is your RHS. Hence proved. Okay. So always one of the safest thing to do when you have all the, everything, all the 6 terms are clearly seen, right? Sine, cos, tan. secant, cosecant, cot. Whenever you have all these 6 trigonometric ratios seen, the best thing to go about is just convert everything into sine and cos and just simplify, solve it, and keep an eye on what you need to prove. Okay, so the minute you arrive at 1 over cos square minus 1 over sine square, that's all, you have proved it. Okay, so I hope you understood. So whenever you have all the 6 trigonometric ratios seen, convert everything into sine and cos and just simplify it. Okay. So let's go ahead with the 13th question for today. Yeah, prove that this is also very similar. So you can see all of the 6 trigonometric ratios, sine, cos, tan, cosecant, secant, cot. So when you have all the 6 trigonometric ratios in the question, what is the best thing to do? Convert everything into sine and cos. Okay, so let's take our LHS and convert everything into sine and cos. So 1 plus tan, right? 1 plus tan divided by 2 sine plus 1 plus you have cot A by 2 cos A. Okay. So 1 plus tan, I am writing it as sine over cos divided by 2 sine plus 1 plus cot, I am writing it as cos over sine divided by 2 cos. Take the LCM. So in the numerator, you'll have cos plus sine divided by cos whole divided by 2 sine plus sine plus cos divided by sine whole divided by 2 cos. Just take the LCM. Okay. And here also I told it's the same thing. So this is nothing but by 1 numerator of the above fraction with the denominator of the below fraction. So this is how it gets multiplied. Okay. So let me rewrite it. So you have sine plus cos divided by cos multiplied by 2 sine plus sine plus cos divided by sine multiplied by 2 cos. So this is nothing but very easily you can see, you can take 2 sine cos, right? So 2 sine cos is common. It's common in both the terms. So in the numerator, you have sine plus cos plus sine plus cos, right? So this is nothing but 2 sine plus 2 cos divided by 2 sine into cos. Take 2 common out. So you have sine plus cos divided by 2 sine cos. Gets cancelled. So just split the denominator into both the terms. So you have sine by sine cos plus cos by sine cos. Okay, sine gets cancelled, cos gets cancelled. What is left is just 1 by cos plus 1 by sine. What is 1 by cos? It is secant theta. Is it theta or a given? Theta, yeah, secant a plus 1 over sine is cosecant a. Okay, secant A plus cosecant A or cosecant plus secant. So this is what you have to prove. This is your RHS. Hence proof. So see how easy this is, right? Once you convert everything into sine and cos and just keep an eye on your RHS. Just go about, do it very carefully. These are the things which you have to be very careful, like taking the LCM when you're solving a numerator fraction and a denominator fraction, fraction over fraction. How do you combine the terms, the numerator of the above fraction with the denominator of the below fraction, and the denominator of the above fraction with the numerator of the below fraction? So these are small things which you have to be very, very careful about. And yeah, taking LCM, solving, simplifying, cancelling the terms, right? So the minute you start to prove, keep in mind that this is what you have to reach at. Then it's very, very easy. Okay, so we have got secant plus cosecant. 1 by cos is secant, 1 over sine is cosecant. Okay. So I hope you understood till here. Okay, let's move on to the next question. So that's the 14th question of today. Again, a very, very good question. One, what you're asked is if cos plus sine is equal to root 2 cos theta, you have to show that cos theta minus sine theta is equal to root 2 sine theta. Very good question. Very important question as well. So let's do it. Okay. Let's write what is given first of all. You are given cos theta plus sin theta is equal to root 2 cos theta, right? Let's have sin theta on one side and take cos theta to the other side. So you have root 2 cos theta minus cos theta. Take cos theta common out. What you have is root 2 minus 1. Okay. Now here we need cos minus sin, right? What you have to do is you have to multiply both the sides with the just the opposite of it. Okay, the way you rationalize it. Okay, take the reciprocal of this. So what is the reciprocal? So multiply both the sides, multiply both sides by, here you have got a minus b. You have to multiply it with a plus b. So what is it? Root 2 plus 1. So what do you have here? Sin theta multiplied by root 2 plus 1, because, okay, see, what you need is root 2 sin theta, right? So root 2 multiplied by sin theta. So this is nothing but, because you have, once you multiply a minus b into a plus b, a square minus b square. So root 2 the whole square is 2 minus 1 square. It will become 1. Okay. So when you are multiplying both the sides with root 2 plus 1 is equal to, okay, cos theta multiplied by root 2 minus 1 already exists. You are multiplying it with the root 2 plus 1. Okay. So this is nothing but, this will become equal to 1. Right? So what you are left with is root 2 sin theta plus sin theta is equal to cos theta. So what is cos theta minus sin theta? Take this to the other end. So what do you have? Cos theta minus sin theta will be equal to root 2 sin theta. Hence proved. Okay, so this is one type of question which is kind of good, because unless you have done this kind of a question, it has to strike you that you have to apply. You have a minus b, so if you multiply it with a plus b, you can apply a square minus b square. So this is nothing but root 2 the whole square minus 1 square. So 2 minus 1, which is 1. So this entire term will get cancelled out. What you're left with is just cos theta. And because you're multiplying both the sides with root 2 plus 1, you are getting root 2 sin theta plus sin theta. So, okay. So sin theta will go to you will just take it to one side, because you need cos minus sin equal to root 2 sin theta. So just do it once, and I'm sure you'll be able to solve it yourself. Now let's move on to the 15th question. Yeah. Very straightforward, and as soon as, you will be able to do it if you know the values. So 2 secant 30. What is secant? It's 1 over cos. What is cos 30? Root 3 by 2. So what is secant of 30? 2 by root 3. Okay. So secant of 30 is 2 over root 3. Just the reciprocal of cos 30, right? Multiplied by, what is tan 60? It is root 3. So this is nothing but root 3 and root 3 will get cancelled. 2 multiplied by 2 is 4. Probably a 1 mark question. Okay. So, hope you understood. So, moving on to the next one. Write the value of sine square 30 plus cos square 60. What is sine square 30? It is just 1. Sine 30 is 1 by 2. So, 1 by 2 the whole square, plus what is cos 60? It's also 1 by 2. 1 by 2 the whole square. So, this is nothing but 1 by 4 plus 1 by 4. When you take the LCM, numerator you have 2 by 4, which is 1 by 2. Moving on to the 17th question. These are all very, very easy questions. Whenever you have to directly substitute the values of specific angles here. So what is tan 60? Tan square 60. Tan 60 the whole square. Root 3 the whole square. divided by what is sine 60 root 3 by 2, the whole square, plus what is cos 30, again root 3 by 2, the whole square. Solve it. Root 3 the whole square is just 3 divided by 3 by 4 plus 3 by 4. Okay, so here you have 3 divided by 6 by 4, which is nothing but 3 multiplied by, you can take the reciprocal, flip the denominator. So 4 by 6. The 6 by 4, when it comes to the numerator, it becomes 4 by 6. So 3 2s are, and then 2 2s are 4. So the answer is 2. Be very careful, okay, when you're simplifying, when you're taking the squares, when you're taking the denominator fraction to numerator, you have to flip it. These are small things which you have to be very, very careful about. Let's move on to the 18th question. Yeah. If x cos 60 plus y cos 0 plus sine 30 minus cot 45 equal to 5, find x plus 2y. Okay, let's just substitute the value x multiplied by what is cos 60, 1 by 2, plus what is y of y multiplied by cos 0, it is 1, plus sine 30, 1 by 2, minus cot 45 is just 1, is equal to, you are given it as 5. Okay, let's just solve it. So you have got x by 2 plus y plus, if you 1 by 2 minus 1, it is again minus 1 by 2. So let me just write it directly. Minus 1 by 2 is equal to just 5. Right? Okay. So what I can do is, I need x plus 2y. So I can take the LCM of x by 2 plus y. So the LCM is 2x plus 2y is equal to, I'll take minus 1 by 2 to RHS. So it will become 5 plus 1 by 2. So the denominator LCM is 2. So again, here you'll have 10 plus 1, which is 11 by 2. Right? And then when you multiply both the sides, so you have x plus 2y by 2 is equal to 11 by 2. Multiply both the sides by 2, so these two will get cancelled. So what you have left with, x plus 2y is equal to just 11. Okay, that's your answer. You have to just find the value of x plus 2y. The value is 11. Let's move on to the next question. Yeah. If 4k is equal to tan square 60 plus minus 2 cosecant square 30 minus 2 tan square 30, find k. Just substitute the values. So you have 4k is equal to tan 60 is root 3 the whole square minus 2 multiplied by what is sine 30, 1 by 2. So cosecant 30 is just 2. 2 the whole square minus 2 multiplied by 1 over root 3. The tan 30 is 1 over root 3, the whole square. So let's just find the value. What do you get? 3 minus 2 square 4, 4 2s are 8, minus 2 by 3. Right? So this is 3 minus 8 is minus 5 minus 2 by 3. So when you take 3 as the LCM, so you have minus 15 minus 2, which is nothing but minus 17 by 3 is equal to 4k. Right? So what is k equal to? Minus 17 divided by 3 multiplied by 4. So, right, this is the numerator. It comes to the denominator. Now, is there any way we can cancel it? We cannot. So what you have to find is just k, right? So this k is equal to minus 17 divided by 12. 4 3s are 12. That's all is your answer. You cannot further reduce it. So this was our 19th question. So let's move on to the 20th question. Okay. But again, a very, very good question. Cos of a plus b is 1 by 2. Tan of a minus b is given as 1 by root 3. And this is not relevant because you are given the sum of the two angles is between 0 and 90 acute. The sum of a and b, not relevant at all. Because in our syllabus, we are only dealing with angles till 90, right? 0 to 90. You have to find secant of 2a minus 3b. First of all, we need to find what is a and b. So let's do it. So just write cos of, you are given a plus b is equal to 1 by 2. Cos of which angle is 1 by 2? It is nothing but cos of 60. Right? This is nothing but cos 60 degree is 1 by 2. So what is on comparing cos of a plus b equal to cos 60? So on comparing, what do you get? A plus b. A plus b is equal to 60. Okay. Similarly, tan of a minus b is given as 1 by root 3. Tan of which angle is 1 over root 3? It is tan of 30. Right? Now on comparing both the sides, so you have tan of a minus b is equal to tan 30. So on comparing, what do you get? A minus b is equal to 30 degree. So let this be equation 1 and let this be equation 2. So just add equation 1 and equation 2 in order to get your a plus. So these are linear equations similar to your linear equations. So a plus b is equal to 60. A minus b is nothing but 30. Just add them. B and plus b minus b gets cancelled. So you have 2a equal to 90 and a is equal to 45 degree. Okay. So you can put in any one of the equations. So put a equal to 45 in equation 1. So what do you get? You have a plus b equal to 60. So b is equal to 60 minus a. So 60 minus 45, which is 15 degrees. So you've got b is equal to 15. Okay, so you have b is equal to 15 and you have a equal to 45. Now what do you need? Secant of 2a minus 3b. So first of all, let's find out what is this 2a minus 3b. 2 into a is nothing but 45. Minus 3 into b is nothing but 15 degrees. What is 2 into 45? It's 90 minus 45, right? 3 into 15 is 45. So this is nothing but just 45. So therefore, what they are asking is secant of 2a minus 3b is nothing but secant of 45. What is secant of 45? Cos 45 is 1 by root 2. So secant of 45 is just root 2. Okay, it's the reciprocal of cos, isn't it? So if you know cos 45, just take the reciprocal of it, you will be getting. So 1 over root 2, secant is root 2. Secant of 45 is root 2. That's it. That's your answer. This is your final answer. So again, so in order to do such questions, it's more important that you learn the trigonometric ratios of specific angles. That is very important. Okay. Okay. So moving on to the 21st question. 21. Next question. Yeah. Prove that here everything is in terms of sine and cos. RHS you have in terms of sine. Best thing is to just keep everything, just solve it as it is, and okay, you don't have to convert anything. So let's take the LHS, take the LCM. Okay, so let me write what is given. Sine plus cos, this is my LHS, divided by sine minus cos plus sine minus cos divided by sine plus cos. When I take the LCM, okay, denominator, it's just a product of the two. Sine minus cos and sine plus cos is the LCM. Okay, so when you take the LCM, the first term would be sine plus cos the whole square plus sine minus cos the whole square. This is how when you are doing it. Okay, now let's expand it using a plus b the whole square. So the first term is a square plus b square plus 2ab plus the second term a minus b the whole square. This one, a minus b the whole square is nothing but a square plus b square minus 2ab whole divided by, in the denominator what do you have? A plus b into a minus b, a square minus b square. Okay, this 2 sine a cos a, 2 minus 2 sine a cos a will get cancelled, right? So what do you have? You have this sine square plus cos square and sine square plus cos square. We know it's equal to 1. So this is nothing but 1 plus 1 divided by sine square minus cos square. But in the denominator, see numerator 2 I have got 1 plus 1 2. In the denominator, numerator 2 I have got it. Denominator I only need sine square. I don't need cos square. So what I will do, I'll convert this cos square into sine square. Cos square equal to 1 minus sine square. So let me do it. So this is equal to 2 divided by sine square minus 1 minus sine square. That's all. And just solve it. So you have 2 divided by sine square minus 1. Minus into minus is plus sine square. So what is sine square plus sine square? It is 2 sine square, isn't it? So 2 divided by, I'm just going to write it now entirely, 2 sine square A, and then there's a minus 1. Minus 1. Okay, 2 divided by 2 sine square A minus 1. This is what I need. This is equal to RHS. Hence proved. Very, very easy. Okay, so the more questions you do, the more you practice, the things will become very, very easier. Okay, let's move on to the 22nd question. Prove that 1 plus tan square divided by 1 plus cot square. Again, you should know what is 1. We should know that. Okay, note. What is secant square? A is equal to 1 plus tan square A. Okay, and cosecant square A is equal to 1 plus cot square A. So now let's take our LHS. So what is 1 plus tan square? It is secant square A. Divided by 1 plus cot square is cosecant square A. What is secant square? It is 1 by cos square. Whole divided by 1 by sine square A. Right? Again, the way I told you to multiply this and this, right? The above numerator of the above fraction with the denominator of the below fraction. So now what you get, 1 into sine square is equal to sine square A by cos square A. What is sine square by cos square? It is equal to tan square A. Hence proved is equal to your RHS. Hence proved. Okay. Very easy, but it's more important that you remember these two identities. I hope it's clear. Please pause the video and make sure you do all of these questions. It will be a very, very good practice for you. The more questions you do, it will, you'll get familiar with all kinds of variety of questions as we go along. So let's move on to the next one, 23rd question. You are given, again, this is something which also we came across with respect to tan theta plus cot, and then you were asked tan square plus cot square. It's of a similar kind. A plus b, sine plus cos is given, but then you are asked sine to the power 4 plus cos to the power 4. Okay, let's do it. Very, very easy question. So let's write what is given. Sine theta plus cos theta is equal to x. First, let's square it on both the sides. Squaring both sides. So what do you get? Sine plus cos the whole square is equal to, we'll have x square, right? So expanded sine square a plus b the whole square, a square plus b square plus 2ab is equal to x square. What is sine square plus cos square? It is equal to 1. So 1 plus 2 sine theta cos theta equal to x square. So 2 sine theta cos theta is equal to x square minus 1, and sine theta cos theta equal to x square minus 1 by 2. Let's keep it as it is. Now, we should also know something else. Just like we did a plus b the whole square, similarly, if I have sine square plus cos square the whole square, how can I write this? This is nothing but a square, sine square the whole square. So sine to the power 4 plus cos square the whole square. Cos to the power 4 plus 2 sine square cos square. Yes. So then this is what I need. What do I need? I need sine to the power 4 theta plus cos to the power 4 theta. So this is what I need. So let me write it. So sine to the power 4 theta plus cos to the power 4 theta will be equal to, this is what we need, right? So this will be equal to sine square plus cos square the whole square minus 2 sine square theta cos sine square cos square. I'll just write sine theta cos theta the whole square. So what is this? Sine square plus cos square is just 1. So 1 the whole square is again 1 minus 2. What is sine cos? So we already know, right? So we can write this as equation 1. So from 1, what is sine theta cos theta? It is just x square minus 1 divided by 2 the whole square. So what do you get here? 1 minus 2 multiplied by x square minus 1 the whole square divided by 2 square, 4. So again you have, what you have is, you have just cancelled it. So 1 minus x square minus 1 the whole square by 2. Take the LCM by 2 because I have in mind what I need in the RHS. Okay, so here you'll have 2 minus x square minus 1 the whole square. Okay, this is nothing but your sine to the power 4 theta plus cos to the power 4 theta. And this is what we need to prove, right? 2 minus x square minus 1 the whole square by 2. Hence proved. Okay. Let's move on to the next question. 24th question. Yeah. This is also very similar. Cos theta, this is something which we have already done, but still, okay, take cos theta common from LHS. What you have is 1 minus 2 cos square theta divided by, take sine theta from the denominator, 1 minus 2 sine square theta. Okay, so cos you can convert it into sine. So cos over sine, so you have 1 minus 2. Cos square, I can write it as 1 minus sine square divided by sine theta, take it out now, so 1 minus 2 sine square. So here you have cos multiplied by 1 minus 2 plus 2 sine square whole divided by sine theta multiplied by 1 minus 2 sine square. Okay, so this question is something which we have already done. Here you have cos multiplied by minus, if you take minus common out, right? You have to take minus common out. Otherwise, I'll just write it in the next step. So cos multiplied by, it's minus 1 plus 2 sine square theta divided by sine theta into 1 minus 2 sine square. So in order to cancel here, see you have a minus 1, here you have a plus 1. Plus 2 sine square minus 2 sine square. So what you have to take is, you have to take one negative common out. So here you'll have, when you take 1 minus 1 common, this will become 1 minus 2 sine square divided by sine multiplied by 1 minus 2 sine square. So now you'll be able to cancel these two terms, which will be left with minus cos theta by sine theta, which is nothing but minus cot theta. Okay, so here again, you have just taken this first term, right? From the LHS, you have only taken the first term. So along with that, you'll have to now add plus cot theta. So you can just write it, therefore, minus cot theta plus cot theta is equal to 0, is equal to our RHS, hence proved. Right? So very easy. Again, now let's move on to our 25th question. So here you have to prove that tan divided by 1 minus cot plus cot divided by 1 minus tan is equal to 1 plus secant into cosecant. So this is something, secant is nothing but 1 by cos, cosecant is nothing but 1 over sine. So the best thing to do is just convert everything into sine and cos. So let's do it. Take our LHS side. So tan is nothing but sine over cos divided by 1 minus cos over sine plus cos over sine divided by 1 minus sine by cos. Just be very careful when you're taking the LCM. So here you have sine over cos divided by, sine is the LCM, so you have sine minus cos plus cos by sine divided by cos minus sine by cos. The same way, combining the upper and the lower fractions. This is how you combine. So it's equal to sine square divided by cos into sine minus cos plus cos square divided by sine multiplied by cos minus sine. Okay, so here you have sine minus cos, here you have cos minus sine. So take negative common out. So this will, when you take minus 1 common, this will also become sine minus cos. Okay, that's what we'll do in the next step. So here you'll have sine square divided by cos multiplied by sine minus cos minus 1. So sine cos square divided by sine multiplied by sine minus cos. So you can take 1 over sine minus cos common, and what will be left inside is sine square divided by cos minus cos square divided by sine will be left, because you have taken 1 over sine minus cos is taken out. Now take the LCM inside. Outside you have 1 over sine minus cos theta. When you take the LCM, it is just cos into sine. So you have sine cube minus cos cube. Okay, again a plus b into a minus b. So you have sine 1 over sine minus cos multiplied by a cube minus b cube. A minus b into a square plus b square plus ab whole divided by sine into cos. Okay, so sine minus cos will get cancelled. And now take a look at what you need. You need 1 plus secant theta into cosecant theta. Okay, so now what you can do is here, what is left is sine square plus cos square plus sine theta cos theta whole divided by cos into sine. Now what I'll do is, in order to get what I need, I'll take this as 1. Okay, so this is equal to 1 plus sine cos divided by sine into cos. So now you can split it up. So this is nothing but 1 by sine multiplied by, so 1 over sine cos, okay, plus sine cos divided by sine cos. So this is nothing but 1 by sine multiplied by 1 by cos plus 1. Okay, so what is 1 by sine? It is cosecant of, is it theta or a? It's theta. So cosecant of theta multiplied by 1 by cos theta is nothing but secant theta plus 1. So this is what I told you in some questions ago. If you have been doing these questions along, this is a scenario wherein we got. Suppose if you need 1 plus tan plus cot, then you should not be converting sine square plus cos square equal to 1. You should not, you just can just split this sine cos among all the 3 terms, in case if that's what you need, right? Tan plus cot plus 1. But here what we need is cosecant into secant plus 1. So that's why we just took this identity wherein we combine sine square and cos square as 1. Okay, so this is what is your RHS. Hence proved. So with practice, right, with more and more practice, as you do, you will be really, really good. Just trust the process of practicing. Everyday practice is very, very much essential. Okay. Let's move on to the next question. 26th question. Yeah. You have to prove that 1 plus tan square a divided by 1 plus cot square a equal to 1 minus tan square. This is again a very good question. Please mark it as important, right? So in both the sides, we need tan square, tan and cot, right? Let's take LHS. What is 1 plus tan square a? It is secant square a. Divided by what is 1 plus cot square a? It is cosecant square a. Okay. And what is secant square? It is 1 over cos square a. Divided by 1 by cosecant is nothing but 1 by sine square a. Okay. So when you combine it, it becomes sine square a by cos square a, which is nothing but it is equal to tan square a. But this is not your RHS, right? So what we'll do is, we'll also take our RHS separately. Sorry. Okay. So whatever we did, right, we took our LHS. It's only till this point we were able to do. Now let us take our RHS separately. So what is your RHS here? 1 minus tan theta, right? 1 minus tan A. I'll write tan A as sine by cos. The whole square divided by what is it? 1 minus cos over sine the whole square. Take the LCM inside. So what will you have? C minus S. Cos minus sine divided by cos the whole square divided by sine minus cos by sine the whole square. Right? So here what you have is C. This term, right? What is this term here? Sine square plus cos square minus 2 sine cos. Here also it will be sine square plus cos square minus 2. So these two terms will get cancelled, right? So what you are left with the sine square by cos square. Okay, so this is also sine square A by cos square A. Because if you multiply here, this cos square minus sine square will be here. Okay, and in the denominator, you will have sine minus cos the whole square, and these two will get cancelled. Okay, both are the same. Is it clear? All of you? So, what is C minus S the whole square? Cos minus, which is cos square plus sine square minus 2 cosine. S minus C the whole square is also equal to sine square plus cos square minus 2 sine A cos A. So, it will get cancelled out. Okay, so these are the same. So what is that equal to? This is also equal to sine square by cos square is equal to tan square A. So you can write therefore LHS is equal to RHS. Hence proved. Okay. Now, so we have done 26 good questions. Let's move on to the next one. 27. Okay. So you have to prove that secant A multiplied by 1 minus sine multiplied by secant plus tan is equal to 1. Equal to 1. Okay. So let's convert everything into sine and cos. So what is secant? Let's take our LHS. Secant is nothing but 1 over cos multiplied by 1 minus sine multiplied by 1 over cos plus tan is nothing but sine over cos. Right? Take the LCM now. Okay, let's keep this 1 minus sine separately. 1 minus sine, I'm going to take it separately. And I'll multiply this with all of these terms. So what do I get here? 1 minus, so this is nothing but 1 by c square plus sine by cos square. Right? So this is nothing but 1 minus sine A. When you take the LCM, it is c square. Numerator, you will have 1 plus sine. Correct? So what is it? A plus B into A minus B. So it's nothing but A square minus B square divided by C square. So what is 1 minus sine square? It is cos square. By cos square, it's equal to 1. It's equal to your RHS. Hence proved. Okay, very, very easy. So you just take your LHS and then convert everything into sine and cos and just go ahead. Okay, so here why did we separate this 1 minus sine is so that because when you combine these, right, when you combine 1 by c 1 by cos multiplied by these terms, you will get cos square and you will get 1 minus sine into 1 plus sine. Okay, so you have to foresee this expression coming, which will be 1 minus sine square, which is equal to cos square, and then you'll be getting 1. Okay. Okay, so this is a very simple, straightforward question. Just that you should know to just keep this aside. 1 minus sign should be kept aside. Let's move on to the next question. So here, prove that, again, see, all the 6 ratios are seen here. You have sine, cos, tan, you have cosecant, secant, and cot. So whenever you have all the 6 ratios in the question, convert everything into sine and cos. Okay, so let's take our LHS. Cosecant 1 over sine minus sine multiplied by 1 over cos minus cos. Take the LCM sine, so you have 1 minus sine square multiplied by, again, cos is the LCM, so 1 minus cos square. What is 1 minus sine square? It is cos square by sine multiplied by sine square by cos, right? So what you have here is just sine into cos. Am I correct? But what do you need? What do you need here? You need 1 over cot plus tan. So what I'll do is I will multiply. I'll convert this 1 into, so I'll convert this 1 into sine square plus cos square. Okay, so this I can write it as sine A cos A divided by sine square A plus cos. 1 is written, 1 is nothing but sine square plus cos square. Okay, and then what I'll do is I will divide the numerator, and because I need a 1 in the numerator, so I'll divide numerator and denominator by sine cos. So what will I get? So sine cos by sine cos divided by sine square plus cos square divided by sine into cos. So this will become 1, right? So this is nothing but sine cos. Okay, so 1 over, in the denominator, what you have to go, well, you just split it. So you have s square by sc plus c square by s into c. Okay, so this will get cancelled. So what do you have? 1 over sine by cos plus cos by sine. This is nothing but 1 over sine by cos is tan A plus cos by sine is cot A. And this is what you need, right? 1 over cot A plus tan A. It's equal to your RHS. And just be very, very careful about this step, okay, here. Because if you just keep this 1, right, you will not be able to get 1 in the numerator. You need something in the denominator. So, cos over sine and sine over cos, isn't it? So you need sine cos. So you are converting this 1 back into sine square plus cos square, and then you're dividing numerator and denominator by sine A cos A, so that you get a 1 in the numerator, and then you're just splitting up, like splitting the denominator into both the numerator terms. So sine square by sine square cos theta plus cos square by sine theta cos theta. Okay, so that's how you are getting to tan plus cot. I hope it's clear. Let's move on to the next question. Okay, so 1 plus secant theta minus tan theta divided by 1 plus secant theta plus tan theta is equal to 1 minus sine by cos. How do you do it? So again, let's use the identity. In the numerator, for this particular 1, right, I can write 1. You know secant square is equal to 1 plus tan square, right? Theta. So what is secant square theta minus tan square theta? Is equal to 1, right? So let's take our LHS and replace 1 with secant square theta minus tan square theta. Okay, plus secant theta minus tan theta whole divided by denominator term, let it be as it is, 1 plus secant theta plus tan theta. Now here what you see here, a square minus b square. So let's split it up and write a plus b secant theta plus tan theta multiplied by secant theta minus tan theta plus you have secant theta minus tan theta whole divided by 1 plus tan theta plus secant theta. So what can you take it out as common? You can take secant theta minus tan theta, you can take it out common, isn't it? So this term you can take out common. So what is left inside is just secant theta plus tan theta plus 1 is left. Whole divided by, in the denominator you have got 1 plus tan theta plus secant theta. So these two terms are the same, they get cancelled. So what is left here? What do you have to prove? 1 minus sine by cos. Okay, so this is nothing but you have got secant theta minus tan theta. What is secant theta? 1 over cos minus sine over cos. Take the LCM cos. So you have 1 minus sine. So this is nothing but you can write it as 1 minus sine theta divided by cos theta is equal to my RHS. Hence proved. Right? Okay. Moving on to the next question. Yeah. So this is also very, very good question. You have to prove that sine to the power 4 theta minus cos to the power 4 theta plus 1 is equal to cosecant square theta. So prove that sine to the power 4 theta minus cos to the power 4 theta plus 1 multiplied by cosecant square theta is equal to 2. So here we know that sine square theta plus cos square theta is equal to 1. So now when you square both the sides, what do you get? Sine square plus cos square, the whole square is equal to 1. So expand it, sine to the power 4 plus cos to the power 4 plus 2 sine square cos square is equal to 1. Right? We need this. So sine square plus cos to the power 4. So here we can write cos square as 1 minus sine square. Right? So sine to the power 4 plus cos to the power 4 plus 2 sine square into, you can write it as 1 minus sine square is equal to 1. Open the bracket. So what you get? Sine to the power 4 plus cos to the power 4 plus 2 sine square minus 2 sine to the power 4 theta equal to 1. So this will become, what is sine to the power 4 minus 2? 1 minus 2 is minus 1. So I can write cos to the power 4 minus sine to the power 4 plus 2 sine square equal to 1. Right? But what do I need? I need sine square. See, I need sine to the power 4 minus, but I have minus cos to the power 4, but I have plus. Okay, so what do I do here? So I can take a negative common out. Okay, so what do I get? Sine to the power 4 minus cos to the power 4 minus 2 sine square is equal to minus 1. Clear? Okay, now I need this term, right? Sine to the power 4 minus cos to the power 4 plus 1. So I'll bring this minus 1 to this side. So what do I get? Sine to the power 4 minus cos to the power 4 plus 1 is equal to, I'll take the minus 2 sine square to the other side. So it will become 2 sine square. Okay. So this is something which we have got. So now 2 sine square, I can write it as 2 by cosecant square theta. Isn't it? So now you can cross multiply. So this is nothing but sine to the power 4 theta minus cos to the power 4 theta plus 1 is equal to. So just cross multiply. So what do you get here? Sine to the power 4 theta minus cos to the power 4 theta plus 1 multiplied by cosecant square theta is equal to 2. Hence proved. Please do this once or twice and do revise it. Only then, it will be clear. Okay, this is quite an important question. Moving on to the next one. Okay. You have to prove that root of 1 plus sine divided by 1 minus sine equal to secant plus tan. Quite frequently asked, let's take our LHS and rationalize the denominator. Okay, so you have 1 plus sine divided by 1 minus sine, multiply numerator and denominator with 1 plus sine. So what do you get here? Root of 1 plus sine the whole square divided by 1 minus a plus b into a minus b, 1 minus sine square. So this is nothing but root of 1 plus sine the whole square divided by cos square. When you remove the square root, what you'll have? 1 plus sine divided by cos. So this is nothing but 1 by cos plus sine by cos. What is 1 by cos? It is secant of a. What is sine by cos? It is tan a. Hence proved. Okay, this is equal to RHS. Hence proved. Right? Let's do the next question. Okay. So you are given tan A is equal to 1 by 2. You have to find the value of cos by sine plus sine by 1 plus cos. Again, very easy. We know tan A is equal to 1 by 2. This is equal to perpendicular by base. Okay, so you have your perpendicular is just 1x. Your base is nothing but 2x. So using Pythagoras theorem, h square equal to p square plus b square. So 1x the whole square plus 2x the whole square. So you have 1x square plus 4x square is equal to your 5x square. So what is your h? H is root 5x. Okay. So once you know your h, p and b, tell me what will be your sine A. Sine is nothing but p by h. So 1 by root 5. Right? What is your cos A? It is b by h, base by hypo. What is your base? 2. H is root 5. So sine and cos you've got. Now just substitute. You have to just substitute the values. Okay. But before we substitute the values, let us see if we are able to simplify it. So what is given there is cos divided by sine A plus, okay, you are given, right? To find cos by sine plus sine divided by 1 plus cos is what you have to find. Let's take the LCM and see if we are able to simplify. Sine into 1 plus cos. So you'll have cos multiplied by 1 plus cos in the numerator plus sine square. Okay. So this, when you multiply, it becomes cos plus cos square plus sine square. Just multiply it inside. Whole divided by what you have? Sine into 1 plus cos. Right? So this is nothing but what is sine square plus cos square? It's equal to 1. Right? So here you have equal to cos plus 1 divided by sine into 1 plus cos. Again, 1 plus cos, 1 plus cos gets cancel. What you're left is just 1 by sine. Okay, so what is 1 by sine? Sine is 1 by root 5. What is sine? We already know it is 1 over root 5. So this goes to the numerator. You just take the reciprocal. It is root 5. Okay, so the value is just root 5 for whatever you have to find, right? So to find the value of this expression, so the answer is root 5. Let's move on to the next question. Okay, so given if sin theta is equal to 12 by 13 and theta is greater than 0 and less than 90 degree, find the value of sine square theta minus cos square theta divided by 2 sine theta cos theta multiplied by 1 by tan square theta. Let's write what is given. From what is given, let us get the value of even cos and tan, right? Okay, so you are given sine theta is equal to 12 by 30. Sine theta is nothing but perpendicular by hypotenuse. So let your perpendicular be 12x and your hypotenuse be 13x. So according to your Pythagoras theorem, we go that h square equal to p square plus base square. Right, we don't know base, so we can write base square is equal to hypotenuse square minus perpendicular square. Right, what is h? H is 13. So 13 the whole square minus perpendicular is 12 the whole square. So this is nothing but 169 minus 144, which you will get as 25. Therefore, you are getting base as 5. Right, 5x or just 5. Okay. So you can now find out what is cos and tan, right? You already know sin theta equal to 12 by 13. So what is cos theta? It is base by pi, by base b by h, right? Base by hypotenuse. Base is 5, hypotenuse is 13. What is tan theta? It is perpendicular by base, p by b. What is p? 12. What is B? 5. Okay, now just substitute and find the value. So what you have to find is sine square minus cos square. Sine square theta minus cos square theta whole divided by 2 sine theta cos theta. 2 sine theta cos theta multiplied by 1 by tan square theta. Just substitute the values. Okay, so what is sine theta? We know sine theta is 12 by 13, right? So 12 by 13 the whole square minus cos theta is 5 by 13 the whole square whole divided by 2 multiplied by sine theta is 12 by 13 multiplied by cos theta is 5 by 13 multiplied by 1 by tan theta, that is 12 by 5 the whole square. Okay, so this is nothing but you will get it as 144 by 60, 13 square is 169 minus 25 by 169 whole divided by, just multiply, you cannot cancel it, isn't it? So 2 into 5, 10. 10 into 12 is 120 divided by 13 into 13 is 169. So multiplied by, you will have 25 by 144. Just take the reciprocal. So 169, when you in the numerator, when you take the LCM, what will you have? 144 minus 25, right? 144 minus 25. So what do you have? 14, 3. So 9, 119, right? So 119 by 169 divided by 120 by 169. So that divided by 169 will get cancelled. Okay, so 120 divided by 169, isn't it? Multiplied by 25 by 144. So here, this is 119 divided by 169 multiplied by 169 divided by 120. Just flip the denominator fraction. So 169 will get cancelled. 25 by 144, right? So 5 5s are 25, again 5 2s are 10, 5 4s are 20. What you are left with is 119 multiplied by 5 divided by 24 multiplied by 144. That will be your answer. So what is 119 multiplied by 5? 45, 5, 4, it is 195. No. 5, 4, 5, 595, right? 595 divided by 144 multiplied by 24. So 4 4 are 16, 8, 8, 2, so it's 6. So 3546. 3546 is your denominator. 24 multiplied by, then it's going to rub all of these. You have to do it on your rough work and not in the main page of your answers. Make sure you give a lot of importance to the way you're presenting your answer. Okay, so what is the final answer that you're getting? You cannot further simplify it. Okay, in the units digit, you have 5 and 6, right? You cannot cancel it. You cannot deduce it further. So the final answer is 595 divided by 3456. Okay, do check it once and let me know if you're also getting the same. Right? Okay. Let's move on to the next question. Okay, so here again, prove that you're given sine square multiplied by sine square theta tan theta plus cos square theta cot theta plus 2 sine theta cos theta is equal to tan plus cot. Best thing is to, let's take the LHS, convert everything to sine and cos. So you have sine square multiplied by tan is sine by cos plus cos square multiplied by cos by sine plus 2 into sine theta into cos theta, right? So here this is nothing but sine square into sine cube by cos plus cos cube by sine plus 2 sine cos. Take the LCM. So you will have sine cos as the LCM. So you have sine to the power 4 plus cos to the power 4 plus 2 sine square cos square theta. Right? So what is this numerator? See, can you see this is of the form s square the whole square plus c square the whole square plus 2 sine square. So this is of the form a plus b the whole square. So this is nothing but sine square plus cos square the whole square divided by sine theta cos theta. Okay. So what is sine square plus cos square? It is just 1. 1 over sine theta cos theta. Right? So I can write it as 1 over cos theta into sine theta. Okay, so this is my LHS. RHS, what is the tan theta plus cot theta? So my RHS is tan theta plus cos theta, cot, right? So sine by cos plus cos by sine, take the LCM. It is sine cos, it's sine square plus cos square. This is nothing but again 1 over sine cos, right? Cos into sine or sine into cos. This is also 1 over, you can write it as cos theta into sine theta. So this is therefore LHS equal to RHS. That's all you have to prove, isn't it? So you just have to prove both the sides are equal. So you were just taking it separately. The next one, 35th question. Yeah. Prove that root of secant square plus cosecant square equal to tan plus cot. Again, let's convert. So 99% of cases, it will help you, it will simplify things for you if you're just converting. So what is secant square? 1 over cos square plus cosecant square is 1 over sine square. Take the LCM within the square root. So this is nothing but cos square sine square. Numerator will have sine square plus cos square. So this is nothing but square root of 1 divided by sine cos the whole square, which is equal to 1 over sine cos. That's all we can do. Just stop it there. Take your RHS also, like the previous question. So what is it? Tan theta plus cot theta is given to you. Sine by cos plus cos by sine. So again, take CS common. CS is the LCM, I'm sorry. So S square, what do you get here? S square plus C square, which is 1. 1 over SC. This therefore LHS is equal to RHS. Hence proved. Okay. Yeah. Next one. You have to express sine A, cos A, cosecant A, secant A in terms of cot A. Very easy. First of all, you should know cosecant, right? Cosecant A. What is cosecant square A? Equal to 1 plus cot square A. So what is cosecant A? Cosecant A will be equal to square root of 1 plus cot square A. So this is 1. Okay, the first identity. You have expressed cosecant A in terms of cot A. Okay, the next one. So now we know what is sine A, right? What is sine A? Sine is nothing but 1 over cosecant A. So 1 over root of cosecant is nothing but root of 1 plus cot square A. So you have also expressed sine in terms of cot. Right? Now, next one. Secant. What is secant? In terms of tan, what is secant square A is equal to 1 plus tan square A. So therefore, I can write tan square A as 1 plus tan square 1 plus cot square A. Isn't it? So when you take the LCM, you'll have cot square A plus 1 divided by cot square A. This is nothing but secant square A. So what is secant A then? Secant A is equal to root of cot square A plus 1 divided by cot of A. This is secant A. Okay. So I have also expressed secant A in terms of cot A. Now cos. So what is cos? Cos A is equal to 1 over secant A. So it's just a reciprocal. So write cot A in the numerator and root of cot square A plus 1 in the denominator. So you have expressed all of these in terms of, okay, secant A in terms of cot A, cos A in terms of cos in terms of cot, sine in terms of cot, and cosecant in terms of cot. right? Using the identities that you already know. So which are the identities that you already know? First one is this. Cosecant square equal to 1 plus cot square. This is one identity. And the other one is secant square A equal to 1 plus tan square A. Something which I have been repeating in all the questions. It will be very, very helpful. Okay. And let's move on to the last question of the day. Very, very easy question. You are given if 5 tan beta equal to 4, you have to find 5. So very, very easy. Just write the given question. So 5 sine beta minus 2 cos beta whole divided by 5 sine beta plus 2 cos beta. Divide throughout by cos. Okay, divide throughout by cos. So what do you get? 5 sine by cos minus 2. Cos by cos is 1 divided by 5 sine by cos plus 2, which is equal to, what is it? So what is sine by cos? It is tan, isn't it? So we are given 5 tan beta equal to 4. So what is tan beta? Is nothing but 4 by 5. So 5 sine by cos is tan beta minus 2 divided by 5 tan beta plus 2. So just substitute 5 into tan beta is 4 by 5 minus 2 divided by 5 multiplied by 4 by 5 plus 2. So 5 gets cancelled. 4 minus 2 is 2 divided by 4 plus 2 is 6, which is nothing but 1 over 3. Okay, so we have discussed nearly, say, 7 different questions from trigonometry, and this is as a part of the weekend revision. If you have any doubts, please do not mind to revise it again, replay the video again, write every question. It's just not sufficient if you just watch the video. Make sure you practice it. Just make a note of how the question is being solved and then pause the video, write the question and you do it yourself. Okay, memorize all those, learn those basic identities. It's just hardly 2 or 3 identities that you have to learn here, and that's it. So the more you practice, it will become very, very easy. See you all in the next video. Just keep practicing, keep learning, and let me know if you have any doubts. Happy learning. Please do share it with your friends and do not forget to subscribe. Thank you.